Good morning, and welcome to Mid-Atlantic Machinery. This is our second event in a four-part series. Today we're going to be focusing on cutting with CNC plasma cutting with ALLtra. Our intent today is to host our customers from Northeast, Mid-Atlantic, and Southern States of Machinery, so thank you for your time. What our goal is to show you how you can make money with plasma. If you currently have a CNC plasma, maybe a larger table will allow you to have greater torch time, on time. Perhaps you can get less scrap and better yield in your materials. A beveling system might be able to help you get additional work. So you might have a laser, and if you have a laser, you're limited to the thicknesses that you can process. Typically, we see with a plasma cutting, up to 1 inch thick material, a plasma is going to run twice as fast as what we're going to see on the laser. If you're a water jet owner, we can run steel 10 times faster than what we can typically with the water jet. So we hope that you can learn about how to make money with plasma cutting, and we look forward in the future to hosting you and challenging us to cut parts or do a time study for you. So why ALLtra? ALLtra is an American-made company. They're based near Dewey, Oklahoma. Their core values are integrity, sincerity, and service, which stands much for the same way that Mid-Atlantic, Southern States, and Northeast wants to do business. So thanks for your time. I'm going to turn this over to Randy Damas and Jerry Hickey.
Thanks for attending, everyone. Today we're going to talk about the latest advances in plasma cutting. How we do things at ALLtra. We'll watch a short video on our rotational bevel cutting unit, and then we'll do some live cutting and answer some questions. Okay, we're going to talk again about precision automated cutting plasma, the ALLtra way. Okay, applications for plasma. Well, there's many. Anybody really who's fabricating metal can use a plasma. So general metal fab, heavy equipment, tanks and vessels, trailers, service centers, mining equipment, overhead crane manufacturing, material handling. All these are prevalent applications for our product. Very versatile process. We'll cut any metal that'll conduct electricity, and we'll do from gauge material to piercing 2-inch material with the XPR plasma series. Other plasma series exist that will cut thicker material, non-ferrous. We have the ability to use full-size plates, 8 by 20, 10 by 20, and specialty sizes up to and including 12 by 60. We use standard grades of steel or even secondary steel and still get very good cuts. The laser process, sometimes you need to buy laser quality plate. There's a little added expense there in order to get the quality you're looking for. Faster cutting speeds lead to you making more money, productivity gains compared to other cutting processes. The latest plasmas eliminate secondary operations like drilling, punching, and grinding. Excellent weldability, and we have bevel capability up to 45 degrees and the ability to countersink down to 9/16 holes. What is the plasma process? Plasma is a thermal cutting process. The heat of the arc melts the material we're cutting. So with the plasma process, we're using an ionized gas stream. The temperature approaches 40,000 degrees Fahrenheit. Melts the material, and the gas pressure blows the molten metal away. Let's look at cut speeds. We'll look at versus laser. So let's take a 10 kilowatt fiber laser system, which will cut about anything you want it to cut. You've got an initial investment of $1.2 million. If we look at a 10 by 24 plasma system, 300 amp plasma, downdraft table, dust collector, software, all the accoutrements, we're looking at an investment of around $300,000. We look at the cut speeds, 1/2 inch steel, 10 kilowatt laser, 87 inches a minute, 300 amps, 155 inches a minute with plasma. 3/4 inch, 59 IPM versus 105, 1 inch, 45 IPM versus 75. So if we look at that, it's 67% or more cut speed at 25% of the investment. You're going to get a high quality production part. So that's a good reason to at least look at plasma. Let's talk about cut quality. That's near and dear to all our hearts. So it's determined by a number of factors. One, the precision of the motion device. You could have the very best cutting tool, But if you don't have a precision motion device, you're not going to get the results you're looking for. We need to match the power output, choose the proper amperage to the thickness of the material we're cutting, and use the proper consumables. Use the proper gases for the process for steel, stainless, aluminum. For steel, it's rather simple. We're using oxygen plasma gas with air secondary. And use the part programming and adhere to the program cutting parameters. Don't go off the chart. Cut quality, there's a number of factors. Angularity is a critical one. If you're looking for a square part or as square as possible, we've taken steps to improve that. The kerf width, the smaller the kerf width, the more accurate the part, the more repeatable your part is. Tighter tolerances means a more precise, repeatable cut. It's what we're all looking for. I think the size of the heat affected zone, depending on applications, welding and so on, less heat affected zone is always better. And limit the dross or eliminate the dross, less cleanup, so on and so forth. Edge quality, also the smoother the cut edge, the more appealing the part will be. So plasma kerfs range from 50 thousandths on gauge material up to 225 thousandths on 1-inch material. ISO has developed a standard 9013 that talks about cut quality, cut angularity relative to the thermal cutting processes. So we'll go into some slides on that right now. So if we look at the XPR 300 at 300 amps, cutting 3/4 inch plate, you see we're in range 3 through the whole range, up through 1400 pierces. So in range 3, our worst bevel angles, 1.5 degrees to a little less than 3.5 degrees. Previous plasma vintages were normally in range 4 or even range 5, and you see that could range up to almost 11 degrees. Major difference. If we look at, okay, now we're cutting 1/4 inch material at 80 amps, you see we're in range 2, which is less than 1.5 degrees, up through 1100 pierces, and then into range 3 up over 2000 pierces. So major improvements in cut angularity with the XPR system. The plasma system, this is hypertherm, what they call X definition. It's their improved version of high definition, the XPR series. There's a 300 amp version, which will pierce through 2-inch mild steel. There's a 170 amp version, which will pierce through 1 9/16. And there's special features for stainless and non-ferrous applications. TrueHell technology is a patented hypertherm process. It, again, eliminates a major secondary operation from previous plasma vintages. So it's a bolt hole quality that's delivered without operator intervention. It narrows that gap that's always been between a laser quality hole and a plasma quality hole. It virtually eliminates the hole taper, makes the hole rounder, and delivers a true bolt hole quality. This is not an aesthetic hole program, it is a bolt hole program. So the goal is you're putting 100 bolt holes in parts, 100 bolts go through without any secondary operation and so on. This is a graphic showing with true hole and without. Those of you who have cut with plasma know that there's usually a taper to that cut. With true hole, that's eliminated. Previously, you may have had to oversize those holes so the fastener would go through or rework them, or you just didn't plasma cut them at all. You drilled them or punched them. With true hole, we eliminate the need for that secondary operation. So if we look at this chart, you see without true hole, the taper could vary up towards 1/16 of an inch, not very impressive. With XPR, with true hole, we're around about 20,000. Lasers around about 12,000. So we're much, much closer than we've ever been to laser technology on that hole quality. These are the parameters for true hole. It is a mild steel process up through 1-inch material. There's 20 programs for the variety of materials up through 1 inch. Standard programs for true hole with the XPR series. So software is a big part of what we do nowadays. Hypertherm ProNest 21 was just introduced last month, superseded 2019, and it simplifies the programming process. This was a big advantage to previous vintages where you had an operator setting amperage, setting gas flows, setting the torch height control, so on and so forth. So all these cutting parameters are embedded in the ProNest 21. So you truly have an operator now. Your programmer selects the 1-inch program, 300 amps, and so on. Your operator loads the program and hits the go button. So ProNest imports these parts drawings, they're DXF files with whatever CAD system you have, be it 2D or 3D CAD, efficiently nests them on the plate, applies these optical cutting techniques, and then generates the M&G code for the controller. Again, embedded technology, what does that do for you? It assures consistent, superior results, operator to operator, shift to shift. And previously, you had multiple operators, you maybe had multiple ways of running that machine, so it virtually eliminates the potential for human error. The motion system, we manufacture this, and it's an XY coordinate drive system, computer controlled, with a Z-axis for the plasma torch. So critical elements, obviously we want high accuracy drive components, a high accuracy height control that's consistent, repeatable, and reliable. State-of-the-art computer control, we use our own control or the Hypertherm Edge Connect control. All of our components are heavy duty, so it's reliable and durable. And we want the unit to be serviceable when it needs service, and hopefully less service than what you would normally require due to the type of components we use. This is a photo of a dual plasma system. You see the controls on the right of the machine. We can put the control right or left. We build bridges up to 30 feet wide, about as long as you can want to go, with up to 4 plasma stations, 12 oxy-fuel stations. This was an article Hypertherm published last fall, basically talks about an XPR plasma system on that motion device. So as it says, even if it's equipped with the XPR and the right software, if you don't have the right motion device, you're not going to get the results we're talking about here. So summarizing that article, not all motion systems are created equal, is basically what that says. So who is ALLtra? Who are we? We've been in business since 1992. We started out as a custom automation manufacturer, building custom welding and cutting systems, and morphed into automated cutting machines. We're privately held. John Arrowsmith is our owner and founder and chief visionary. We're American-owned, American-made. We're headquartered outside of Tulsa, Oklahoma, and have 140,000 square feet of manufacturing across 3 buildings. And first and foremost, at our heart, we're an engineering company. John's a welding engineer by trade, and that's who we are to this day. And why ALLtra? Well, what we call the ALLtra way and what Kevin Kilgallen likes to call the ALLtra way. We work closely with our customers from start to finish on your application, from inception to implementation. We've always been a service-first company. This comes from John Arrowsmith. He cites examples when he was growing the company through the 90s, people in the Pacific Northwest wanted to buy machines from us, and John said, look, I can't sell you a machine now. We don't have service people up that way. So he waited till we had enough service people before we would sell in various areas. And all of us know companies that have maybe put the cart before the horse. John's never done that. And we offer a fully integrated formula from the design of the machines to controlling all the manufacturing. We do it all in-house, to installing and training on the machine. These are ALLtra technicians, not third parties, to supporting the machine as long as you own it. Again, why ALLtra? Our machines are built to last. All of our machines are designed around a 24/7 specification. They're rugged, accurate, and dependable. All of our replacement and wear components are standard items. There's no proprietary parts. Our end users receive a list in our manual not only of our part numbers, but also the vendor part numbers and a description. We offer a myriad of productivity options, and one of our most popular is the rotational bevel head. We'll talk about that in a little bit and watch a short video. We have extended Z-axis slides that we manufacture up to 40 inches long for doing dome headers and special application. Automatic torch spacing for multi-torch systems. And we make pipe cutting equipment. We have standard standalone pipe cutting equipment, but we also offer a pipe cutting combo that works in conjunction with your plate machine. We simply make the bridge wider. This pipe combination system sits inside the rail next to your support table, and the same head that cuts plate comes over and cuts pipe. Service and support. Every ALLtra customer from day one receives lifetime 24/7 telephone support free of charge. So off hours, we have people assigned to answer the phone. You simply dial our main number, and it's forwarded to somebody's cell phone, and they take care of your issue, work you through it. We offer remote support and diagnostics through the controller for your machine. We also offer programming software support. We do not use a third party to support the software. We have people on staff that only support our software customers. They're not involved on our hardware side. In addition to the training you receive on install, you receive a follow-up visit 30, 60 days later on training. And for the first 12 months after install, you receive free training when you need it. Maybe you get a new application, maybe you've hired a new operator. All we ask for is 2 to 3 weeks notice so we can schedule a guy to come out. But again, it's free of charge, including the travel expenses. We have technicians stationed around the country. They don't all live in the Tulsa, Oklahoma area, so we're not always flying people out from Oklahoma. So we have people in Virginia, Houston, Georgia, Ohio, quite a few people in Oklahoma, Houston, and in the Pacific Northwest. So we're able to get to our customer base more efficiently than everyone flying out of a central location. And we have annual and semi-annual preventive maintenance programs we offer. So full contour rotational beveling. This is an infinitely rotational bevel head. We can do basically any type of bevel cut that you would want to do. These are the type of bevels we do. So you see the V edge, the Y, the X, the K. So with our rotational head, there's not a bevel that we can't cut. Applications, initially, vessels and tanks were the biggest application because those were always done by hand. Over the years, as the technology got better, the cutting technology got better also. So weld prep became a very big application, replacing these manual operations. Maybe you were using track burners or other types of simple automation, and mechanical beveling systems. Mechanical beveling systems put a great bevel on, but if you're going to weld the material, it's very, very slow. If you're cutting harder materials, they're impractical to use on 400, 450, 600 Bernal. And recently, due to technology changes, advances we've made with our bevel head, we have the ability to countersink these fastener holes down to 9/16 of an inch, which saves virtually incalculable amount of money compared to other ways of doing. Initial investment, round about the type of systems we're talking about, start at $175,000 and work their way up. If we're looking at a typical full contour bevel system, say 8x20 plate, 300 amp plasma, downdraft table, dust collector, software, all the trimmings, round about $400,000. Operating costs, again, depending on material thickness, alloy, depending on what your power cost is in your part of the country, $7 to $15 an hour, including the power, consumables, gases, and maintenance. So all this information is available on either our database, our hypertherms, and technical data sheets that we publish. We'll have questions shortly. Right now, we'd like to show you the bevel video. now. Again, we're opening the floor for any questions relative to plasma cutting, motion control, software questions, service after the fact. Okay, we have a question on thicker material. How does plasma compare with the oxy-fuel process? Well, we still sell oxy-fuel cutting machines. We sell a lot of combo systems with plasma and oxy-fuel. So as we spoke, the XPR 300 system will pierce and cut 2-inch mild steel, and we'll be cutting at about 21 inches per minute. That's about twice as fast as an oxy-fuel torch on 2-inch. You're normally 10 to 12 inches per minute. Now, the advantage oxy-fuel has, a couple of them, we can use a multi-oxy-fuel torch. So if I have 2, 4, or 6 oxy-fuel torches, depending on the size of the part, we can get 4 to 6 of the parts at the same time. There is preheat time with oxy-fuel, so that slows us down, but there are some productivity software modules to reduce the amount of pierces. We can use common line cutting to, again, get 2 parts with 1 pierce as opposed to 1. Another advantage of oxy-fuel is if you do need that 90-degree cut, oxy-fuel will give that to you. There will be some slight bevel, as we discussed, on a plasma cut. Okay, another question, what gases do we need to run with this system? It's material dependent. So again, mild steel is easy. It's oxygen plasma gas with air secondary. In the 30 amp range, sometimes there's air settings. This is all controlled, again, via your programming. So it's not up to your operator to do these settings or choose the right gases. So you leave your gas bottle, the gas valves open, the program will open the proper solenoid valves. If we're cutting stainless, aluminum, non-ferrous, one of the advantages of the XPR is we have the ability to run nitrogen and water. It also has the ability to run argon, hydrogen, nitrogen mixtures. But with the nitrogen and water, we get that very nice finish on aluminum, stainless. We remove those oxides. They don't form because we're using water. So you get a much cleaner part, weldable part, very good looking part with the nitrogen water system. So standard industrial gases, no specialty grades. Okay, we're going to do some live cutting now, and we'll bring Jerry Hickey back into the picture here. This is a part that we cut on the machine earlier. That part's going to be relatively warm. But you can see the sharp corner here. You can see the radius, the quality of the TrueHole technology. That's the top. And that's the bottom. So again, a minimal ding at the start and stop of the hole, round at the top, round at the bottom, same size. And you can see the smoothness of the cut edge, the sharp corner, minimal dross, and a very smooth cut edge. You want to cut like 2 or 3 of those in a row? Any channel locks or anything? And this is the part we just cut. Those first two short sounds you heard, that was actually marking. So we have built-in marking with the XPR system. We mark and cut with the same consumables, and as you saw, it automatically changes over from marking parameters to cutting parameters. We use air or nitrogen to mark. We can also use argon with the XPR series, which on stainless and other non-ferrous alloys, the argon makes a very big difference in the quality and the clarity of the marking, particularly if you're doing letters and numbers. But crosshairs, bend locations, those sort of things. So we just pluck that off the table. Whoop. You look on the underside, you see a little dross on the radius cuts because we slow down to get that quality. That dross knocks off very easily. A little bit in the corners because we're decelling into the corner and then accelling out to get that sharp corner. Again, you see that sharp point and the smooth radius, smooth cut edge. Jerry's going to cut some more. Oh, okay. Okay, question, what is your cut tolerance on that part? Again, it's half-inch material, so we'll be no worse than 20 to 25 thousandths, plus or minus. Probably a lot better than that. I don't have a micrometer to measure right now, but easily within 20 to 25 thousandths. Any more questions? Okay, we'll cut a few parts here. You could watch the height control sequence, and this would be simulating a nested sheet. They're going to go to the screen side of the controller. Okay, welcome back, everyone. What we're going to do now, Jerry's going to go through the programming system in the CNC controller. We're going to put a screenshot up for you, walk through the programming sequence, what a nested sheet looks like, so on and so forth, and feel free to fire over any software questions.
What do we got? Oh, okay. This is a basic home menu. Basically, to run a program, you go to Run. We just finished this sequence. We can do Job Done. We can pick any of the other options that we have currently loaded into the control. As you can see in the parts up here, they're changing as we go through to give us a graphical description. We have some additional parts. Of course, we've got some fun ones too, but a particular nest, this could have been a nest, it could have been 2 parts, or it could have been 300 parts. Once we select it, we go through a process of selecting some options on this particular screen for setup. If we're going to run in automatic, or if we want to do a test run in order to be able to determine the part fit on the plate, or and move it as necessary to make it fit on a plate. Then we can come back to this same screen again and go into the automatic mode and go ahead and do a full cut of that part by changing to automatic and then switching directly back to the next screen. Once I've selected any options I want to do, I can also include rows and columns, which right now only have 2 parts. I can increase that to, in this case, I could increase it quickly to 4 parts as a row, or we could switch it to add an additional number, and now I've got 8 parts. This was 2 parts to start with. I've got 8 parts that I can do real quickly, directly from the console without having to go through the nesting software, but it's a simple array. Once I've completed that, I can also do plate alignment. Plate alignment's a really useful feature for most of the operators that allows them to set a plate on the table without having to physically straighten it parallel to the rails. Especially useful on the heavier plate. Pick 2 points with a laser pointer that he's guided, and once he picks the 2 points, it sets that angle into the plate that includes all of my particular positions. And once he's picked 2, it changes the angle of the plate to match whatever angle that plate was setting at. And once we've established where we're going to put the part and cut it on the plate, basically at this point the operator ensures he's got good consumables in his torch that match what the programmer's established for the plate thickness, and he hits the start button. At that point it should run the part. In this case I'll just allow it to run in test mode. Oops. You do have to have the process turned on. And on the graphics, you can see a cross here that shows us our particular position on the part as it's cutting. In this case, we're test run. We're not actually physically cutting. But this would be a sample of where an operator would be test the plate to make sure everything's going to fit. I'm not sure if you can see the laser pointer on the plate. Yeah, the camera doesn't have a good angle on the laser pointer, but the operator would have a laser pointer for a reference if he wanted to use it. Occasionally you can see it up in the right-hand corner when it moves around. Right now I'm over a currently cut part, and obviously an operator wouldn't want to do that. But anyway, it'll automatically sequence through all these 8 parts that we've got set up there in one start without the operator having to start and move it again to cut the next part. Any additional questions?
Diagnostics and anything.
The other options that we have are for diagnostics on the plasma system on this particular control. Literally in this one, when we go to status, I can do an update. It'll show me options on here of what particular errors that might show up. In this case, we're showing a 716 error, set process denied. That was because we had the process turned off, or the station turned off when we tried to run the program. But it'll give us, and Hypertherm is very detailed on what their troubleshooting error codes are. Their manual shows, and this is the customer's manual, shows detailed information on all the error codes that show up in their system so that you can troubleshoot from in-house, or you can troubleshoot with our support either by phone or one of the service guys out in the field.
Okay, we have another question. Does the control... Oh, I need the mic. Sorry. So does the controller move with the cutting head on all models? The answer is no. We do offer a pedestal mount CNC that does not travel with the gantry. On larger machines, it's preferred so the operator stays near the cutting process, if you will. But on smaller machines, higher speed machines, a pedestal mount control is preferred. And you can have it on either side. There's about a 7 to 10 foot umbilical cord, if you will. So you have some limited mobility with the pedestal. The gantry CNC, again, we can put on either side of the machine, no additional charge. I got a couple other cut samples I'd like to show you. One's a bevel sample. This was done at a customer shop. You have to bear with me, I'm not as young as I used to be. But this is a bevel with a land on 1 3/4 inch steel, as cut. And you look at the underside, virtually no dross, a little bit in the corners. And this was 300 amps. Look at how sharp those points are, how clean that cut is. And you see the underside. You do have some dross on the underside of the holes. Why? Because we're cutting slower to get that hole quality. That dross knocks off very easily. This was cut on a customer machine that was 8 by 50 cutting area, downdraft table, one 300 amp plasma torch, 1 oxy fuel torch. So that's the quality our bevel head can give you. This is a 1/2 inch stainless steel sample cut with the nitrogen water process. You can see the edge quality there. Very clean, no oxides. Stainless is a little more challenging because of the way the metal behaves. If you look at the underside, minimal dross at the start and stop. Virtually no dross on the perimeter edges. You do see a little ding at the start and stop, but again, part of that's because of the way stainless behaves. But if this were a fastener hole, a fastener would easily go through there. You see some corner rounding here. We can eliminate by using the corner looping feature of the ProNest 2019 software. So we simply loop the corner to maintain that square edge if that's going to be an issue. And then here's the top. Again, let's look at that edge quality on the stainless. Again, this is a nitrogen water process. Much, much different than probably what you've seen plasma do on stainless steel in the past. Okay, another question comes through. What is the maximum thickness you can cut on stainless steel? With the XPR 300, it's a production 1.5-inch stainless machine. However, there's other plasma series to cut thicker stainless. So the HPR 400 XD will cut up through 2-inch stainless and edge start 3.25, and the HPR 800 XD is designed specifically for thick stainless and non-ferrous applications. An 800 amp plasma system. It'll pierce 3.25-inch stainless and edge start up to 6-inch stainless. Very impressive machine. Any more questions? Okay, we have a comment and a question. I have the HPR 260 XD plasma system. How many consumable parts are now being used on the XPR? The HPR 260 XD was the predecessor to the XPR 300, and there were a full part change for every amperage range. So you had to change the shield for every amperage range, a number of the water tube, a number of other parts. So the XPR, they didn't eliminate any parts, but we used the same shield, the same water tube on multiple amperage. So there's probably 50 to 60% of the parts in comparison to the HPR XD series. The HPR 260 XD also had standard cutting consumables and bevel cutting consumables. The XPR is one set of consumables. So we have one set of consumables up through 300 amps for mild steel, one set of consumables through 300 amps for stainless and non-ferrous. Any more questions? Okay. So again, if you've liked what you've seen here, contact your regional Mid-Atlantic, Southern States, Northeast Machinery Sales representative, and we can schedule a teleconference, a video conference, depending what state you're located in. We can schedule an in-person visit, and certainly once we're through the pandemic, we could start getting back together again. If you want time studies done on certain parts, send us the DXF files. We can do cut samples for you. This machine is in Mid-Atlantic Machinery Showroom in Harrisburg, PA, and is here to do demonstrations and so on. So please contact us if you'd like further information.